everyone, welcome back to the channel. So in this video, we'll tackle a classic algorithm problem, which is removing duplicate from a sorted array. So we'll walk through the problem, discuss an efficient solution, and then dive deep into the coding and see how the solution works. So the question is, we are given with a sorted array, and our task is to remove the duplicates in such a way that the element appears only once in the given array, and the array should remain sorted, and we need to return the new length of the array. Okay, so the given array here will be any given set of elements, and in that we need to make sure that only once the value appears. So here in the example nums is equal to 1 1 2, we need 1 comma 2 in the final output array, right? So how are we going to solve this? We'll use two pointer technique, and the solution is we use the first pointer high, which travels through the array from the second element onwards, and then the second pointer j, which will keep track of the position of the last unique element. So we'll start with I at index 1 and then j at index 0, and we'll see if nums of I is different from nums of j, and increment j and update nums of j with nums of I. And then finally, the length of the array with unique elements will be j plus 1. Um, let's try let's try coding this and see if it works. That is, if not nums, then return 0. And the initial value for j should be equal to 0, and for I in the range of 1 comma length of nums, right? And here we need to check if nums of j is not equal to nums of j. Actually, this should be nums of I and this should be nums of j. And then increment j is plus equal to 1. So this is equal to j plus 1. And nums of j will be equal to nums of I. Right? And then finally what we need to do is return j plus 1. So here what we're trying to do is um, we start by checking if the list is empty, and then if it's not, we initialize j to 0, and then um, as we iterate through the list of I, we compare nums of I with nums of j, and if they are different, we just update the nums of j with nums of I and then increment j. Finally, we return the j plus 1 as a position of the length of the array. And the time complexity of this solution is O of n, where n is a number of elements in the array. And seems like we've made a mistake here. Yeah, this shouldn't be there. And space complexity of the solution will be O of 1. What is the, okay, I've put a double brackets instead of single brackets. The space complexity is O of 1. What is this? Nums of I is not equal to nums of j. Then j will be equal to indentation issues. Yeah, so it's submitted and then it accepted both the cases, and then let's submit and see. And to summarize this, we just learned how efficiently we remove the values from the sorted array. And see, if you see the solution, it is accepted. Then it ran in 82 seconds, and it beats 75% of the solution in memory, and then runtime it beats 27% of the solution. If you found this video helpful, please give a thumbs up and then subscribe for more content. And let me know if you need any questions or topic to be covered in this channel. And yeah, thank you for watching. See you in the next one.